All right, so we are ready for the September 9th live forum event for the Propeller 2 chip. So the only thing I have to announce for today is the video for the last week's event. I'm not sure if you saw it's in the forum. So now with the new format, it's split into two. So you will see there are 4 links. There's one for the discussion, one for the presentation section, and then there are 2 more links for the chat. So we also are posting the chat text files there, so you can see anything that we said on the side. And again, we will be recording this from my connection. So if you see that I drop off, I will try to get back into this live forum and resume recording as soon as possible. So for today, we have Jeff starting on Propeller 2 documentation. And I hand it off to Jeff. And I need to stop sharing. There you go.
Thank you, Ari. Okay, so I'm gonna share my screen here. Okay, so everybody should know that we've been working on some documentation behind the scenes, some like official documentation in the form of the data sheet and the spec sheet before that up until now. And we're continuing to make some updates there. There'll be some coming updates here probably in, I don't know, around the end of this month. And further updates when we can continue our categorization of the Propeller 2 on the new rev of the Edge board. So keep an eye out for that. But what we're showing today is one that we just released today, which is the Propeller 2 hardware manual. And I'll show you where you can get that. If you go to our, everybody's seeing my screen, I imagine. You go to the main website, Propeller 2 documentation. And right now it's available down here as a commentable draft. This is what it looks like currently. So I want to give you some idea of what this is. So many of you are familiar with the Propeller 1 and the Propeller 1 manual. I assume you can see this. It's a pretty hefty book. It's actually 400 pages. And it includes, everything about the Propeller 1 hardware and the spin language and PASM. And as I've been going through, what I've been doing is going through every piece of documentation that we have and asking lots of questions of Chip and trying to piece it all together and rearrange some things to present it in a different way. I guess similar to what I kind of naturally did with the Propeller 1 manual. And it was pretty obvious that when it's all said and done, it would be one really huge printed document if you printed it out. And we also didn't think that that was, going to be conducive to the way things are now. Of course, everything's online, and we are writing this stuff so that it can be printed. But I wanted to kind of break things down a little bit more. So the Propeller 2 hardware manual is intended to cover mostly hardware details, special things about the Propeller 2, and then bring in some code, specifically PASM 2 in this case, where needed to demonstrate, how to activate a certain feature or utilize a certain feature. So in addition to hardware, we'll have some software examples, some source code examples, but where that's the case for now, at least it will be just PASM 2 examples. And then we will cover the other languages in other documents. And the main point I want to get across here is that we're trying to make this hardware document conducive to other tools that the community has developed for other languages too, for like C or Python perhaps, so that we kind of make it as much as possible language agnostic. So that's what the idea is behind this document. And if you've gone through the data sheet or the Silicon doc, you'll see a lot of similar information. And it's hard to point to something that's like absolutely like a big section that's brand new, but there are sections in here that are brand new, things that I've written from what I've learned from the document talks with Chip. So I'll just kind of scroll through some things here. And just so you know, just today I was asked, okay, so how far along is this? I think it's about 75% complete for this document. And it's still smaller than Chip's Silicon doc, but as I've gone through, there's a lot of information that I've put in here, and it ends up taking a few less pages, and partly because of just the way I'm formatting it, but also because there's some information that I think is more fitting in a language document, so I'm saving it for that. Let's see, so what I've been doing is trying to go through and really think about it from a user's perspective of trying to find information. So on the left-hand side here, the outline, I've been doing a lot of work thinking about how things are presented, the order they're presented, and trying to make this really nice so that you can jump between big subject targets quite fast here. And then also with the thought in mind that we're going to make this very searchable in an even different format than Google Docs in the future. So that's the big picture of the whole thing. This one thing I wanted to show you that I've got a little boot up pattern diagram here for that works for a lot of the boards that we've developed. Let's see, let me show you some things that are kind of new. If I can remember where they are. Here's one. Okay, so here's a little section on the instruction pipeline, which I don't think was in the Silicon doc. I pulled it from the instructions.txt file where Chip has all the PASM2 instructions. And I dove into this because there was something I learned about RAM that I wasn't quite understanding the timing. And so I started looking at this and then realized, we need to bring this up front and document it so other people who might go down the same path as me, can rediscover the same thing. So there's a section on this and how everything overlays, how the instructions overlay in the pipeline. The next thing I'll be doing here is adding in what happens when there's a wait state, like what Chip calls a stall, where the pipeline is stalled, everything's waiting for a particular instruction to get access to the resource that it requested. Yeah.
Could you zoom in on your staggered execution? In the instructions.txt, I did this using ASCII, and I kind of staggered them so that they would each kind of fall down like this, so they could. Anyway, this is kind of a simpler illustration. So let's see, we read the I, we read the RAMD, we latch the I, get the DNS, latch the I, the ALU, and writes the result. Yep.
And then they overlap by 3 clock cycles.
Right.
Right.
That's good.
Yeah, I was. This is Chip's first time seeing this diagram. I actually just finished it last night. There are some things I want to do to it, but I was trying to take what he showed and see if we could rearrange it so that it's a little bit easier to follow, because I know that I had trouble following it on the ASCII art. I wasn't quite understanding it until I talked to Chip. Obviously, we can't have everybody talking to Chip all the time. So I'm hoping to get a little bit more of a simplistic view in diagrams like this so that it just kind of makes sense. And I see that I've got some things here that I didn't change. You always find bugs when you go demonstrate something to people, right? So again, this is a work in progress. You can jump on it. It looks like there's somebody else that's on it right now, and make comments. I really encourage everybody to take a look, make comments about what's there, anything that you don't understand, but also especially I'm looking for anything that people want to see here or want to find out more information about, because I don't always know what you guys are looking for. I just know what is a mystery to me. I go searching for that, write about it, put it in here, and then try to organize things. So keep that in mind. If there's something that's absolutely missing or that you think should be explained differently, please feel free to share.
Oh, I already got one.
Oh, good.
I think you're missing the thing where you can use the ZQ plus WR long with an immediate, and that will then fill memory instead of copy.
Yes, yes. Yeah, in fact, there was some part to the way that the RAM access is that I didn't understand at the time that I was writing this section. And even though I had read the Silicon doc, I learned it from Chip, so I know about that. I do intend to put that in.
Hey, Jeff.
Yeah.
I think the only other things you need to show in there are what happens when a stall occurs for whatever reason, and then what happens when a branch occurs. Why does because it has to assert the new instruction address, then it has to get that. So it costs 2 extra cycles because you have to dump 2 clocks worth of state in the pipeline that was for the instruction that you're not going to execute after all, but had been picked up.
Yes, good idea. So I already have a diagram in the works for what happens when there is a stall. And I realized late last night, or actually early this morning, that I'm not sure I designed it right. There's a couple of questions I have, so I'll have to talk to you, Chip, about just to make sure that I have it right, because I actually took it out just before we released because I think it was technically wrong. But so I'd like to fix that, and then you're right, I need to make a diagram first showing what happens when we do a pipe flush. So let me write that down actually, so I don't forget it. Okay, so just show you a couple other things here. So the Cortex solver section has these nice little links that you can jump right to the little blip about it and little example code. I imagine that we'll have some other deeper examples later that we will probably link back to in here. I don't know if those examples will go in this document or not. And smart pins, all the smart modes are listed in here, and they're all linked also, so that you could jump right to the section that demonstrates that. And then host communication for anybody that is trying to make their own tools, perhaps, explains how that works, documents all the instructions, and even talks about, down here somewhere, about the interactive modes with the P2 monitor and tacos. Although this section is really light, and admittedly, I want to expand on that and also take some examples from the documentation that's out there on the forum, and I think there's a PDF for tacos somewhere out there too. At the end here is actually a little table of reserved words. This is SPIN2 and PASM2, and this is going in the language documentation. I'm sure it's pretty hard to see on the screen. I had to try to squeeze everything in so that it was nice and concise. And so I know there's something I wanted to mention, but I forget what it was. I just, again, want to emphasize, please go visit this doc and tell me what's wrong with it. And I will continue on my route of enhancing it the other 25% of the way till I think it's complete, as well as writing the language documentation, which I actually started just a few days ago. So does anybody have any questions?
Hey, Jeff, I kind of do.
Okay.
So I naturally just, if I have something to add to the docs, I go to that big Google file, right?
The Silicon doc?
Yes.
Yeah.
And I put it, so are you going to be like periodically looking at that for any changes?
Yes, in fact, I do that. I haven't mentioned it to you, but I note what version I'm using last, where I pulled the information from, because what I'll do is I'll peel off a copy of that so that I'm not messing with yours, and I can make notes to myself about what I've documented or what I've, carried over into other documentation and what I have yet to do. So I go look at the dates, and then I go check out the revision history for anything that you've done, some things that Michael has done, perhaps, and also some of the comments from people, which usually you've already addressed. So I take a look at that stuff and absorb them in. So you don't need to tell me about something in particular unless it's, topical and you want to point it out to me. Otherwise, I think I will find it and put it in there. And I know in the near future, we're going to have floating points. So I haven't even gotten to that point, of course, to where that's a problem for me, but I'll be, taking whatever information you have. I imagine you'll put that in the spin docs.
Right.
So yeah, feel free to just continue editing your Silicon doc, as you see fit.
Okay. It's funny that we're able to work like that these days. It's kind of like open loop. It's like functional programming.
Yeah, it is. I don't know that it's always, I don't know that it has advantages, disadvantages. It's nice for everybody, just so everybody knows, Chip and I don't always get a chance to talk. And when we do, it's usually a big information dump between us. And I'm always learning something that I didn't know before I started the call. So I thank him for helping with this and being really responsive to my naivety about certain things, and just
well, we're all in it together.
Yeah, I wish I could. I told Chip I wish I could have started documenting this a much longer time ago, but other projects got in the way and I couldn't dive into it. But now I'm actually at the point where I'm starting to really have fun. So I kind of dream about this stuff. Wake up in the morning, I'm ready to go.
Yeah, once you get in the flow, things get somehow nicer. Huh?
Right. Yeah. And a lot of the problem that I had was, trying to come up with the big picture right up front. That's really hard to do. And looking through all the docs that we do have, there's just, I think Chip would agree, there's so much more to the Propeller 2 than there was the Propeller 1. So I feel like I have most of the Propeller 1 details in my head somewhere. And the Propeller 2 is just this grandiose big world that I've yet to discover certain gems.
Yeah, we were talking, Jeff and I were talking that the trouble is, the thing is, it can do a lot, but it's complicated enough that it's hard to, I suppose, work within the attention spans of people these days that expect everything to be highly intuitive. So we've been talking a lot about how we can formulate future development tools to kind of progressively develop people's skills rather than have them construct all the mental models in their head from reading, which is abstract, and a lot of people don't have the patience for that anymore. So we've got to come up with some bridge to get something like Blockly at one level, but then PASM at another level.
Yeah.
And spin in between.
And on that note, I do remember now what I sort of touched on it, that I do have plans to take all this documentation that we've developed and make it available in a different form that's not, one big long document that you scroll through, but rather a bunch of topical articles so that you can really swiftly, bounce back and forth between little snippets of information or focused, statements about how a certain function works. Hopefully all linked into the Propeller tool or whatever development tool we're using, and make that stuff available for others too, so that they can link it into their tools, or at least provide a quick way to go get to it on the web, and of course to make it all findable on simple Google searches as well. In fact, one of the things that I found out, let me show you one other thing. I'm going to share my screen again. I hope you're seeing everything fine. But what I wanted to point out is in Google Docs, if you just do a Control F to go find something, like for example, I wanted to find all the instances of the system counter name, right, which is just capital C, capital T. Of course, this finds everything. It's a case insensitive. So you guys have probably seen this where you can match case here. Now in this doc, there's 51 instances of this, but there are other things that this is part of. I think in the Silicon doc, when I searched for this, I could get down to about 153 instances. But I knew that most of those were just the letter CT in caps in some other word. So I encourage you to take a look at using regular expressions. You can turn that on and enter the right syntax here. And I was able to completely drill down to everything I wanted specifically for that, for just such a generic little search. So that's just a little tip within Google Docs. And of course, in the future, I hope to make it even simpler to get to that stuff in the web presentation that we provide of this same material.
That's looking great.
Yeah, thanks.
Jeff, do you want to talk anything about software availability, like the pieces to make for developers, or in a future event?
I can talk about it a little right now.
That came up in last discussion. Ada was interested, and I think Michael too.
Yeah.
And what we are going to do in the future, part what we have now and what it should be.
Okay. Well, so I don't know what. Wait, is this the? I'm sharing the wrong thing here. Wanted to show this. Okay, so as far as I understand, the question came up from somebody or maybe multiple people who wanted to have access to the source code for certain tools in order to maybe enhance it or build their own tools. And we used to have some things shown on our old website way before we started using GitHub. And I think you can still get to that by this little link up here. In fact, I might have opened it up. Yeah, here's a page from our old site. So what I did is went to the regular site, clicked on Access Old Parallax Site, and then just searched for open source, and came to this page where we had kind of organized some things. Of course, none of this applies to the Propeller 2, so it's probably a moot topic here, except maybe this, the Parallax Serial Terminal source code, an old version is there. But Ari asked me to speak on this, and so I thought I would show what is out there, and then talk about what we are going to do, what we need to do. And we already just started scratching the surface of it. So this page, by the way, that you're looking at is just I searched for open source on our current website and found all of these things. Some of them are the Propeller tool software, but we need to get a lot of this over on GitHub. Oh, this is actually just the software, not the source. So some of this doesn't apply. But so here's what I intend to do. I know that there's been some requests for the Parallax serial terminal, and I will be putting that on our GitHub page so that you can go take a look at it anytime, dive in, suggest changes, or just take what's there and use it for your own use. And Chip started another repository here so that he could store some files that everybody needs, that everybody wants to see in the Peanut IDE. So I think he'll be populating that here in the coming days.
Oh, wait,
and
Jeff, you're talking about the repository you helped me set up?
yes,
Yeah, I'm still messing around with this floating point printing. So once that's done and that's all tested, then I'll put all the files into that thing, and then we'll put a link on the forum to it.
yeah, which is this P2 Peanut public repo that you're seeing right here.
Yeah.
Right now, I think there's just just one file. It was just a little test file that we threw in there, although that is necessary for compiling the project.
So Jeff, since I have you at my thumb, actually, because I'm pressing my space bar with the thumb. The main problem, I think, which needs to get solved, and I think Würfel would help there, and I would try. The main thing is that all that graphical display stuff, debug stuff, basically should belong into PST and not Prop Tool or Peanut. Because
you're talking about the debugging features.
The basic, you can turn it around like you want. Either you put that into PST or you put a debug terminal screen, input output, into the debug stuff. But can you somehow get that Delphi code separated that we can make this simple sort of without Peanut, without compiler, without prop tool, just without those third-party just those debug screens and the serial terminal in a single executable Delphi, whatever you have. And then me and Würfel can maybe try to get that running in Lazarus or Freeze Pascal, that we have it running independent of operation system.
Okay, I see what you're saying.
Would be the right, in my opinion, PST is the right place to have, or build some other PST2 which has debug screens and another screen which does simple serial input output. So combine that in one, and you don't need to do it in Prop Tool and in Peanut, just in that thing that like LabVIEW. I mean, you could even feed it with a P1, or hell, even out of a basic stamp, you can send out those serial commands to show a nice scope display or whatever.
I see what you're saying, so that it could be used, it could be even more general purpose.
Right, and if and Peanut and Prop Tool are not as easy to get kind of platform independent with Free Pascal or Lazarus or the Delphi Community Edition 2021, but adding to that graphic screens terminal window, so I mean, in one package would be really the solution we need. And if you could do that with your existing tools for Windows only and give us a source for that, we could probably get that running with more compatible libraries than Free Pascal or something.
Okay.
That's my thinking about that, because that would be a nice product. Even, I mean, you could even use Blockly Proc and send commands out to that debug program. It's just backticks in the serial stream, but we need a terminal debug windows also, which has to be input-output, and that standalone somehow,
All right. Yeah, I can understand that. In fact, we were we didn't get really deep into it, but at some point, I think Chip and I were talking about, or at least I was thinking and suggesting to him that I wasn't sure what to do with Parallax Serial Terminal in light of the fact that we had this debugging stuff that I was integrating in the Propeller tool. So I thought, well, should I get rid of it? Or I mean, should we just not use it? Or should we make it auto activated and become that, the terminal, the little terminal that it usually appears underneath the IDE edit screen.
And we just need another debug, graphical debug screen, which does a simple terminal, so it's in the same suite.
Yeah.
Get rid of PSD completely and try to get that standalone, the graphical screens and the terminal, which kind of catches everything which is not a debug command. Everything which doesn't have a backtick goes there.
Yeah.
So my 2 cents is the debug screens are excellent and we should keep them. And the only thing I'm using the PST for with my students is for inputting data from a keyboard to the Propeller 2. And we've talked about this before, that because of Windows and the way it works with the serial ports, it's not easy to do that. But I was thinking maybe if we had some kind of a special command to send through the debug that's like the wait key was in the old keyboard objects for the P1. So somehow to wait for a key for an indefinite amount of time or wait key for a specified number of milliseconds and then give up and keep continuing the loop. So that's my the only reason I still need the PST for the curriculum I'm creating to try to teach mechatronics to engineering students and other students at the college level, for those of you who haven't caught up to what I was doing back in May during these forums. One thing I'm thinking about putting in my kit is some kind of a USB keyboard for a number pad to be able to just have that talk to the P2 through USB, completely independent of the debug. But in my opinion, if we've got a good way to enter data from the computer's keyboard that's running the Propeller tool through the debug, that would be the ideal solution. And then in which case we don't need the PST for anything else anymore.
Okay. Yeah, that was something that.
Gavin, hold on. Gavin, can you say the last bit again?
Yes, I think that the debug in terms of this graphic capabilities really makes the PST terminal obsolete. And the only thing that the PST still has that the debug does not have is the way to input data to the Propeller from the PC running the Propeller tool. And that's something that I was still using the PST for with my students. So if we had some way.
You're doing it not on the PC side, but on the Propeller 2 side.
That's one way around it was to try to get an extra keyboard, which adds cost to the kit that I'm trying to bring down with Ari and Stephanie.
Right. So it would be better if it could use the PC keyboard, you're saying.
Exactly, yes.
Okay.
And the PST allows you to do that. And I use that a lot as we're entering data, for example, PID gains or something, we want to try to tune a system. So we need some way to be able to enter data easily to the Propeller. And the PST terminal right now is the only way to really do that easily. So adding some kind of capability to the debugging that allows you to get a key. Again, it doesn't have to be live, all the time. And you could add a special command like get key or wait key in order to do that. But I think that would really. I
just need to make the debug interactive, and then that'll be there.
Okay, excellent.
Gavin, just with the MicroPython effort, we Gary J has a USB serial USB host object which you can use for direct keyboard entry into the P2. So you could actually just go direct to the P2.
Yes, that was the plan with this, was just to give up and use some kind of a USB breakout and get it right into the P2. But ideally, this is an extra $10 to charge students or customers. That it would be better if the PC they already own that's running the Propeller tool could just enter it in, and that the PST does that right now.
Yeah, so to put it in words that Chip understand, kind of very simple. I need to do that. What we need would be a debug command or kind of debug command which gives a wait key 25 milliseconds, and if there is a key we can do something with it, else don't. That would be the simplest way. Not interactive debug, just the way to check if there is some serial input key and use it. And the same is just output on, I mean, building a terminal debug screen, which just basically outputs what is not debug information on the same port. Because basically, if I want to run PST, I have to run PST and I need a second port for my debug. If I could do that over the same port, it would be way nicer.
Well, you know, I could just, I mean, without fully implementing bidirectional debug, I could just add a command to the current debug thing, which would wait for a key. So it would it wouldn't be always receiving asynchronously, but at the time that it went into that command, it could initialize pin 62, right, as the RX pin, and it could wait for some data to come in and then pass that back to the program being debugged.
And then you have a simple key input. I mean, you can put kind of a small routine which made out of many keys, a string or whatever. But if you have a command using your debug serial interface to get a key, check for a key and get a key. I mean, that's a simple -1 if there's none there, else give me the key. That would already help a lot. And some debug screen which outputs everything which is not the debug screen. Just simple terminal output on the screen. Whatever you send to that debug pin or will either trigger one of your displays, and if it doesn't, it should get out there on a screen. One window showing all those characters which are not debug characters.
Right. Gavin, is it most important just to have a keystroke, or do you want to look for a particular keystroke?
I think one, whatever, none or one, just a command in debug where you can say, I want, if there's key, if none is there, -1, else ASCII 0 to 55. I mean, that would already be fine. You can put around, and then we can even connect it to the send or receive or whatever, and we are done.
We have some input from John. John, do you want to unmute yourself and say that? He's asking about, you know, he's using more features than just sending some text back. Has a lot of programs that depend on it.
Yeah, I think, you know, it always frustrates me when I hear people arbitrarily say, well, let's just cut the guts out of this, when some of us have been using PST for our demos, which I do a whole bunch of, for a very long time. So I would be very irritated to have PST go away. Now, I could, I guess, if there was a debug window that could do what PST does, but there isn't. All the debug windows are made to be fun and fancy and not terribly practical from my point of view. So you know, maybe, you know, this sadly puts more work on Jeff's plate, but he's used to it, right, Jeff? I'm looking for you to you know, so that we could select from Propeller tool if we want to use debug output or we want to use a terminal output. And further to that selection, I'm sure there are some people that don't like PST as much as I do and might want to use another terminal. Perhaps then we could have a future version of Propeller tool, say, where we're going to use a terminal and this is the program I want to load up, if that's possible. So if you wanted to use real-term, for example, instead of PST. But please, you stop the talk of just that it's okay to throw away PST. It's not.
That's not what I was suggesting. It's already in the Propeller tool. I don't think we should take it out. I don't see the need to make it standalone. I think you can probably find it and make it standalone.
No, PST is standalone.
Yeah, it is standalone. It's included with the Propeller tool. Well, I mean, it's included with the Propeller 1 software, and I guess in the Propeller 2 installer.
It does work with Propeller 2. You just hit F12 and you get the PST popping up.
Right. Yeah.
So all
yeah.
I'm suggesting is we take the functionality of the PST and try to emulate that with the debug so that we can do the same kind of stuff. And in terms of, John brought up some good points about all the stuff that's already been written for the PST. If we use the same method names, it might just be a simple matter of just changing the alias definition up at the top to be able to have whatever you're doing before working with some other driver that just does the same thing with debug. So I think we should try to keep the same, like get decimal, get binary, things like that for the method names.
Yeah, and I think I'm the one that said that I was considering, what should we do? Should we exclude PST and just stop using it? And it was just kind of a passing thought at the time that not to just get rid of it, but to, go to something, if there was something that was capable of doing that stuff and more, through some kind of merge. And at one point, I think I had talked to Chip about absorbing the debugging tools into PST actually, which is what started this topic. And there was, I believe that I chose to go the other way because it was more integrated and could respond faster. And I had a heck of a time getting things to work as it was. So it was just easier to work in it that way till I got it solved. But I'm still of mind to, consider doing it a different way and not necessarily get rid of PST, but maybe enhance PST.
Yeah, I mean,
but still, you would still be able to, I think, like what John was saying, sorry, I didn't mean to cut you off. We could always make it so that it's possible to specify through some setting in Propeller tool what you want to be assigned to the F12 key for a terminal.
yeah. I mean, we have that Node P2 terminal also, which is can be ANSI compatible. So we have kind of colors in it and something. But basically, in my opinion, we have two choices here, and John is right. And PST as is should not go away. I mean, it is as is good. Either integrate the graphic screens into it, or Chip has to do one debug screen, which kind of is a terminal where you can output on the terminal, but then it should work without debugger. So that's something which I also think about a lot. If you have that in the debug, we have already kind of using the USB port to output, but then you can't use the terminal. FlexProp has a terminal built into the load P2 thing, which is a different terminal. Configure also a good idea, but somehow we are running around here. Either integrate, in my opinion, the simplest way would be to build a debug screen which does a simple terminal like PST does, and an object to it to use it even if you run the program without debug, and there we are getting in trouble. That is something Chip has to figure out. Spin has no standard serial output except to do with whatever JM serial.
It is possible already to.
In FlexProp, there is for C and Basic, there's standard input output, and there is some driver. I mean, like simple. I mean, direct input output, and Chip is using that in Spin also now with debug, but you are not able to use those debug existing routines in debug to output your own string. So what kind of giving him an object you could include which uses a debug output for serial terminal instead of, I mean, I don't know, something like that. I mean, I'm grabbing strings here right now, or straws or whatever you say in American. But basically that needs to combine.
It is possible to change the function of F12 in the Propeller tool just calls up an external executable, and so you can replace PST. In our case, we replace it with a chain of things.
Yeah.
So you just call it PST, whatever program you need in the chain, and then that program can call PST, or it can call some other, debug display, and so you can hook all that onto the existing infrastructure. For more advanced users, if they want to just change how it functions or how it operates. It's useful if you want to do some kind of data transfer or something like that before you get into the terminal.
So Lachlan, since you were talking, I think we're talking enough about this right now. So people is kind of thinking we can talk more next week, maybe, or later in the discussion. So you want to jump in and present about the P2 485 temperature?
Sure, it should be pretty brief today, I think. So yeah, share screen.
Cool.
All right.
Yeah, but I think yeah. Oh, there it's cool.
All right. So that's on the screen, okay, the presentation. Yeah, so today I just want to, I suppose just recapping on what we talked about last week. We're doing some work with driving RS-485 signals directly from the P2 using an array of resistors to set up a circuit. The FETs inside the P2 have strong enough drive to be able to send RS-485 level signals out to interface to industrial devices. And so we're just working our way through a number of devices to communicate. Last week, we talked to one of these Advantech Atom industrial modules, and this week I just want to talk about an industrial RS-485 temperature transmitter, which we have, which is this unit here. This has been kind of half disassembled, but it comes in a long tube, and you can see there's the RS-485 and voltage connections there. There's a dip switch for setting the address. You can have 255 of these on a network, and there's a little, similar to a sense ion sensor at the end there for reading the temperature and humidity, and a microcontroller here for translating that into meaningful RS-485 signals. So what we've added onto the network this week, just to make it easier to debug, these little USB to RS-485 transmitting dongles are only, around $10 mark. You can even get them for $8.50 at Mouser. And they're just a simple device, but one useful thing is they do put out 5-volt power, so you can actually interface to some field devices straight up, or you can step up that voltage from 5 volts to 12 or 24 volts like we're doing. So I think we've covered the temperature transmitter there. The only problem I'm having with these, which I guess we'll come back to later, is that there's a lack of data and code on the net to sort of get this thing actually up and running and talking properly. But we're still pushing on that front. Just to get started with this, it's possible to download a Modbus scanner. So this device uses Modbus RTU, which is a popular bus protocol published by Telemecanique years ago, and widely quite easy to interface to. The only thing that's sort of slightly tricky is that it's got like a CRC on all the packets which go out and in on the bus, but really widely used, and that's why we're experimenting with what the P2 can talk to, make sure it can talk to industrial drives. So there's a program on the net called Radzio Modbus Scanner, and that just makes it easier to get started talking to a device. It enables you just to measure and look at holding registers which are inside the inside the Modbus protocol. So in this case, address 0 on the screen here is showing a value of 999.9. That's the relative humidity. and address 1 has got the address, the value 149.9 degrees. And at the moment, that's what the thing puts out until it gets set up with compensation, etc. So we had that successfully talking just for that little USB transmitter to the PC. The next step is to sort of start formulating packets so that we can hook the P2 up and have that talking directly to the device. So in the window here on this online checksum calculator, I've put in the desired Modbus packet, talking to address 01 using command 03, which is to interrogate the holding registers. And then you have this null data and the number of bytes you're requesting in the packet. Once you've got that string, you need to go in and calculate the CRC, which comes back as C4OB. And then we're putting that information into the P2 tool to send out the packet, which is happening on the left-hand part of this crow capture. And you can just see the last of the CRC transmission there with the OB. So that's the P2 transmitting at the left-hand side. And then over on the right-hand side, you've got the response back from the industrial device. So that's saying this bit here, this it says receiving 4 bytes. And then the 03 E7 is the humidity value corresponding to 999 or 99.9% humidity. And then you've got a 05 dB, which corresponds to 149.9 degrees Celsius. So at this point, I'm kind of happy, I'm just getting responses back. I'm driving it from the P2, the electrical level translations are working, etc. So I'm sort of happy at that point that I've got communication, even though I haven't got the exact temperatures I'd like to measure. And that to do that, I sort of need some more information. I've got the sum of all the information I've got is really the little Chinese data sheet, which came with the brochure, which came with the temperature measuring device. And I found there's also like some instructions on the DF Robot website. There's about 8 pages of data, but unfortunately it sort of stops short of being actually useful to talk about how the device works internally. So it just talks about, how to send and receive packets. But that much is kind of discoverable anyway. So I'm just sort of missing that missing link of some example code. And I'll just have to sort of fumble my way forward a little bit with that. But to be honest, it's already doing what I want to do for my purposes, and I'm going to sort of move on to industrial VSDs for the next session. Yeah, so that's pretty much it for the temperature side. So any questions on that?
Lachlan, you said you were sending the data and you showed it. Are you using just a standard serial object on one of the 2 pins, and then you said you mirror on the other?
I'm just using the smart pins in the async TX mode to send out the data, and async RX mode to bring it back in. The trick we talked about last week is really to just use the smart pins to mirror, so that you get the differential drive happening between an adjacent odd and even pin. And from that point, you can use anything, whether it's just a smart pin mode or whether it's a like an FDS or a similar kind of object to do the transmission. So I guess this is more at the sort of hardware layer, just, how to actually get the electrical levels correct that we're experimenting with, and just making sure that it does indeed work and talk to various devices. But you can use any method on top of that, whether it's the raw kind of smart pin modes for serial transmission, or you can use any of the software objects. It's all kind of compatible. It's just the only difference is how you set up the smart pin in the first instance to get that kind of RS-45 level translation.
So the same pin is used for transmit and receive, and then the other pin is mirroring the transmit?
Yeah, there's we've been experimenting with kind of bus turnaround, so like where you have using the same pins to both transmit and then you put it back into receive mode and bring things back. But frankly, it's kind of easier just to use the ability to spy on a pin from a couple of pins away and just leave that spy thing in a permanent sort of receiving mode. And that way you've always got the data received. So you're not, in a kind of a nice final object, it'd be nice to just have it so that, yes, it does turn around, does have the bus turn around. And as you can see, there's about maybe 3 milliseconds between the P2 ending transmission and when you've got to pick up the incoming received data. And this is a fairly slow 9600 board application. But yeah, we haven't really got a, I'm not even sure whether there will be a final object for this, because what we're really discussing is just a technique for using the smart pins to aid data transmission. And so really you can apply it to any of the serial modes, but we'll probably wrap it into a kind of a demo thing. So if people want to replicate what we're doing, then at least you can, just buy some hardware from Mouser and get as far as we have.
Lachlan, the code for this is probably pretty small, huh?
Yeah, it's just about 20 lines of code in total.
So it's in assembly.
Yeah, it's in assembly. It's in ugly assembly because we're arranging and putting things in and out just to try different approaches. But you're right. It's not. There's really not a lot of code. But I guess, for some people, the assembly is a little bit intimidating. But for what Brian did a lot of the setup work on this, and he's used a combination of, spin for most of the setup work, and then just the assembly for the smart pin interactions, I guess. But you could have it completely in either, spin or assembly, and or any other language really. So.
Modbus is really easy too, in that it's a half duplex situation, and the protocol defines when, the timeout period. So if, for example, in your case, you are doing a request, you expect something to come back. In Modbus, you may have just a command sent out or a global value that doesn't require anything. I did a spin driver that has an assembly driver with a spin interface for Modbus a long time ago. And it turned out quite easy. And I think given the capabilities of the P2, it would be even easier now. The timeouts are always based on the baud rate in Modbus.
Yeah, I forget that there's like 3.5 bit or character periods or something that it causes a bus. Like if you just have it idle for that period of time, then everything.
Yeah, it's a reset.
Yeah. Yeah, so that's it for me. I'll stop sharing.
Looks good. Thanks for showing us that.
Yeah, thank you, Lachlan. And this will end the presentation part of this live event. And we are thinking for next week, we will be talking a little bit about RAM. The P2EC RAM board that is coming. So we have Michael is doing the PCB design. He will be talking about that. And since kind of RAM related, Graham could be doing an update on his project, the P2 arcade machine that you saw in the forums. And if you want to hear about any project in particular, or if you have something to present, just let me know and we will add it for next week or the following week. We are trying to assign some projects that are kind of related in some cases. Okay, so let's close this session and we start the discussion right back.